Hello everyone. In this video I'm going to talk about how you can route all the three phases through your inverter. Definitely at one point in time you will need only one phase, but how it should be done. First of all, we need to understand what is the need. Uh, at times what we have is there is a problem with any one phase, or generally due to over load at the transformer, or due to monsoons as they're around. Many times there's a problem in one phase of grid energy, or so, and that phase is connected with your inverter or some important device, and you want that the other phases are diverted to that load. So in my case it is the inverter, because I don't want my batteries to drain out, because I don't have a big battery bank. So if there is any grid power, I need that to go to inverter, so the battery keep charged. So when I want when there is no grid or solar, then I can use the battery. So this is my need. So to resolve it, I have to uh, route the three phases to one inverter. So the hardware need is the two automatic switches. They are called GQX62F2Z. So this is a two-terminal switch, and you will need 6 mm lugs and wires. So this is the hardware requirement. So let me show you the auto switch so you can understand how it works. So this is the switch, right? And let me open it up for you. So this is the switch. So it has two ports here, here, and there are some connections. And so you need to understand that when you see these wires, this is the output, right? So this is the output. When you see these wires, right? So this is the output, and if you can see the movement, let me try to show it to you. Right, so this is how the switch works. It is up once you have the magnetic force created down, so this will move down and connect to the other terminals. So this is input, and this is output side. So when you see these wires, so this is the output side. Okay, so if you divide this into two, one side is positive and the one side is negative. So positive and the neutral. And what else? These are these connectors, this and this. These are the triggers. When you give power to add these connections, this will trigger and this will trigger down. So this is how it works. So what else? Generally what you do is you connect these down here. This one is connected down here. So when there is power, so this is pushed down and connect, and this is used as output. So input, and output. This is how it works. One side is negative and one side is positive. Negative, positive, negative, positive, negative, positive, and these are the triggers down there. So this is the simple explanation of this. Let's get back to our presentation. I hope I will be able to make you clear how the switch works. So we need two switches for this, and let me explain you this diagram. This is how I have wired. So this is phase 1, phase 2, and phase 3, and this is my backup switch and this is the live switch. So phase 3 goes to one input and this is also connected with the trigger, right? So when this one get powers, this power will always go to inverter. This is always there. But what if this power is not available? Then the power will come from the switch. So phase 1 and phase 2 are the two connections over here. So any of these, whichever is coming, is being used as output. The output is the second input of this switch. So these two phases, whichever is coming, will go to this switch as second input. Whenever the first input is not available, the second input for either of the these phases will go to the inverter. So this is how I've designed that is implemented, and you can see that all the neutral wires are common because this is all coming from one grid and there's one common ground, or sorry, neutral. So this the neutral side you can keep it common for even for the output also. What matters is this power line, the red line. This should not be connected because there are 3 different phases and you have to route the phases like this, that the phase which is in the output switch will go first, and if this is not available then phase 2 or phase 3 will come from this switch and as a second input to the switch. So this is the simple wiring diagram. I hope that you will be able to do it. This can be your AC, this can be your fridge, this can be anything, but for me it was my solar inverter. So this is how it looks like. It's a jungle of cables in my distribution box right now, but because this is work in progress, so I think I can live with it for some time. So these are my under overcurrent breakers, and from here the power goes to this meter, and from this meter it will go to these switches, and then it will go out. So only one phase I have designed, but you can use 6 switches, and you can route power of 3 phases to any device of your home. But for me it was I need one output, so this is good enough. So that's it. I hope this will be useful for some. Bye for now.